Okay, good morning to all. Then again, welcome back. In the last class, we have discussed about the Kalama transition technique of single round and the multiple round. So today we are going to discuss about the Burnham cipher. This is the one-time pad algorithm. Plain text character will be represented by the numbers as a equal to 0, b equal to 1 and c equal to 2 and z equal to 25. Add each corresponding number of a plain text mesh to the input ciphertext alphabet numbers. If the sum is greater than or equal to 26, subtract 26 from it and translate each number back to corresponding letters, and we got our ciphertext. So here you have to plain text character will be represented by the numbers as a equal to 0, b equal to 1, c equal to 2 and z equal to 25. So here that means you have to numbering the alphabets from A to Z, but starting from 0 and end at 25. That means the starting letter is A, which is serial number is 0, and the end letter is Z, which serial number is 25. Next question. Next step, add each corresponding number of a plain text message to the input ciphertext alphabet numbers. If the sum is greater than or equal to 26, subtract 26 from it, translate each number back to corresponding letters, and we got our ciphertext. Here, first our plain text is include help. So first you have to write include help INCLUDEHELP, and you have to put the serial number against each alphabet. I is your 8. Suppose you start from 0, A is 0, A0, B1, C equal to 2, D is 3, E is 4, F is 5, G is 6, H is your 7 and I is your 8. Similarly, N is 13, C is 2, L is 11, U is 20, D is 3, E is 4, H is 7, E is 4, L is 11, P is 15. So this is the serial numbers. Right now you have numbering that plain text. Next is your one-time pad. One type pad is given. That means one type pad means it is a key is given. Here A, T, Q, X, R, Z, W, O, P, Y, B is given. So here A, T, Q, X, R, Z, W, O, P, Y, B. You have to also put the serial number against each alphabet. A for 0, T is 19, Q is 16, X is 23, R is 17, Z is 25, W is 22, O is 14 and so on. Next is you have to add all the two serial number. That means here 8 and 0. You have to add 8 plus 0 is 8. 13 plus 19 is 32. 2 plus 16 is 18. 11 plus 23 is 34. 20 plus 17 is 37. This 3 plus 25 is 28. 4 plus 22 is 26. 7 plus 14 is 21. 4 plus 1 is 5. 11 plus 24 is 35. 15 plus 21 is 36. So this after the addition, next step is that if the sum is greater than or equal to 26, if the sum is greater than equal to 26, subtract 26 from it. So look here, after the addition, this 32 is greater than 26, 34 is greater than 26, 37 is also greater than 26, 28 is also greater than 26, 6 is equal to 26. Next 35 is also, here 35 is also greater than 26. 36 is greater than 26. So here whatever, if the after the addition, if the result is greater than equal to 26, then you just subtract 26 from that number. Suppose 8 remains same, there is no problem, but here out of 32 just subtract 26, result is 6. Next 34 subtract 26, result is 8. 37 you subtract 26, result is 11. 28 subtract 26, result is 2. Then 0, 21, 5, 35 minus 26 is 9, 36 minus 26 is 10. So this is the your so to subtract 26 from each answer. Next, whatever the ciphertext, then is the last step, translate each number back to corresponding letters and we got our ciphertext. Now against 8, whatever the serial number of 8, now I, 6 is Z, 18 is for S, 8 for I, 11 for L, 2 for C, 0 for A, 21 for B, 5 is F, 9 for J, 10 is K. So this is the ciphertext I, G, S, I, L, C, A, B, F, Z, J, K. So this is your ciphertext. So this is the Burnham cipher, or is known as the one-time pad. So these are all about the transposition technique. First is your Ralph's first transposition is your Ralph's technique. Second is your Kalama transposition technique. Under this Kalama transposition technique, there is two things, basic techniques, and second one is your multiple rounds, and last one is your Burnham cipher, and next come to the symmetric and asymmetric key cryptography. First come to the symmetric key cryptography. Symmetric key cryptography is sometimes called secret key cryptography, or in other terms, data is encrypted and decrypted using the same key. An encryption system in which the sender and receiver of a message share a single common key that is used to encrypt and decrypt the message. So this is about your symmetric key. Symmetric key cryptography, sometimes called secret key cryptography, or you can other term, data is encrypted and decrypted using the same key. Right, for the encryption decryption, both case the same key is used. An encryption system in which the sender and receiver of a message share a single common key that is used to encrypt and decrypt the message. Similarly, asymmetric key cryptography, asymmetric encryption uses two keys, one to encrypt the data and another key to decrypt the data. These keys are generated together. One is named as public key and is distributed freely. The other is named as private key and it is kept hidden. Both on sender recipient has to share the public keys for encryption and used to use their private keys for the decryption. So here asymmetric, in that case you are using two keys. One is your public key, another one is your private key. Public key is the shareable for both the sender and receiver for encryption, but in case of the for private key, this private key is used for the decryption method. So symmetric key cryptography use one secret key or one same key for both the sender and the receiver, but in case of the asymmetric key, there are two types of key. One is your public key, another one is your private key. Public key is distributed freely, while private key is kept hidden. Public key is used, or you can say share, for both the sender and the receiver for encryption, but in case of the private key is for the only for use for decryption. So this is all about your chapter number 2, and next class we are going to discuss about chapter number 3. So thank you to all. Thank you.